multiplication of polynomials. We did the adding and subtracting them together. Now we're going to multiply them together. So a real quick refresher here. What is x plus x?
X. 2x.
How many x's do I have? I have one here, I have one here. I have two total x's. Okay, cool. And then if I had like 5x to the fifth plus 2x squared. Whoa.
You cannot do it.
You can't do it. You can't do it because these are not like terms. Okay? Not do it. Well, I guess you would say 5x to the fifth plus 2x squared. You can't simplify it any further. Now, if I do multiplication here, okay? Wow.
Wow.
Invisible marker. If I do, good enough. If I do multiplication though, x times x.
Just x.
Interesting.
It's 2x. No, 1x.
It's x squared.
X squared. That's the whole point of squaring, right? Now, let me just plug something in here. Let's say x is 3, right? So what's 3 times 3?
6.
Oh dear.
Oh, 9.
3 times 3 is 9, okay? 3 times 3 is 9. What's 3 squared? 9. That's what it is, okay? So this is something times itself that many times, right? So that's literally what this is, okay? So what's the exponent on this x? What's the number? How big is the exponent? 2. What's the exponent here?
1.
1. What's the exponent here?
1.
A thing you have been taught before, but just a refresher. Whenever you multiply numbers, you add the exponents together. So I have 1 plus 1 is 2. That's why it's 2. Another reason why. Okay. Let's do this thing again. Let's do 5x to the fifth times, this time, 2x squared. Okay. So, whoa, that looks crazy. But this is super easy because what's 5 times 2? That's normal. 10. X to the 7. 5 plus 2 is 7, right? But I really want you to see 5 and a 5, a 2 and a 2. Was it 10x to the 10th?
No.
No, you don't do the same thing. Numbers are multiplying. Their exponents are adding. Make sure you remember that. It's a big deal. All right. So what we're doing today is this. I'm going to show you in a broken apart way and then together and then one final thing. So in fact, I'll do it right here. If I had x times x plus 3, okay? What would I do with this x?
You would times it to...
This is multiplication, right? This is a multiplication. And I would take x and I would do x times x and x times 3. What's that called? Distribution. That's huge. Okay, that's a big one. So x times x, we just talked about that. That's x squared. X times 3 is 3x. And that's what this one would be. Done. Okay. Now, I'm going to do another problem. I'm going to take the same x plus 3, and I'm going to multiply it by 5. Okay. So now I would do 5 times x, and I get 5x. And 5 times 3, don't forget to do both, and I get 15. Yay, done. Okay. Now let's do this at the same time. Here's what I mean. I'm going to do this parentheses times this parentheses, and that's what today's all about. I'm going to put x plus 5 here and x plus 3 here. Why does that look familiar? And why do you think I kept looking over there when I was writing this?
Because you just basically...
Because you have to distribute.
You're going to have to distribute, right? This is x plus 3 in both of these, which is right here now. On this one we did x, on this one we did 5. Okay, so here's what I'm saying. If you don't catch what I'm saying, here's literally what's going on. This is being multiplied times this. Okay, how many things are in here?
2.
There's 2 things. How many things are in here?
2.
2. I'm trying to talk simply for this reason. All right, I'm going to take each of these things and pair them up with each of these things.
The common.
Simply enough. Okay. Back in the day, I taught Algebra 1, and when I taught Algebra 1, I had literally 4 people stand up here with. And I like duct taped stuff to their shirt, an X, a 5, an X, and a 5. And they're all standing here. And here's what you do. This person right here, what do you think I'm going to do with this X?
Move it.
Move it?
More like...
Distribute.
Distribute. Okay, multiply. Okay, cool. So X times X. And then I'm gonna do what with the same x?
You're gonna times it to the 3.
X times 3. So I literally had this x person walk over to the, and shake the hands of the other two, and then walk back, trying to be visual descriptive to the freshmen, you know what I mean? But I'm gonna do x times x. I'm gonna stay color coded here, and I get x squared. X times 3, 3x. And that is the same thing I just did a second ago right here, right?
Mm-hmm.
And now I'm gonna do the second step, which, what do you think, whose turn is it now?
5.
It's 5's turn, right? 5 times x
5x.
is plus 5x. 5 times 3 is plus 15. Okay? Which is right there. Oh my God, we just did that.
Wow.
So, now, why do you think I taught you guys adding and subtracting first before we did this? What do you think you have to do now? Adding. Combine like terms, yeah. Okay. So I have x squared right here. Nobody else is an x squared. Cool. I have my x's right there. Cool. That's plus 8x. Combine like terms. And then the 15's all by himself, so plus 15. Cool. And that's your answer. Okay. That's what you're doing for every single one of these. You're just taking everything here and multiplying it times everything there. Okay. I'm going to take this one step farther now. Okay. I want you all to go crazy and weird. Okay. Throw in letters all over the place. We're going to throw X's and numbers all over the place, and we're going to do something absolutely crazy. Okay.
Banana.
What?
Banana.
We're not doing shapes this time. Okay. We had apples last time.
Shape it's a fruit, coach.
We're gonna do
There's a difference.
true. Sorry, we're not doing objects of any kind. So this
Square.
first one is going to
20.
be a. We're gonna keep it simple. 2. Oh, sure. I heard a 3. Sure. We're gonna do 3
9.
x plus y. Whoa.
81.
Crazy. All right. And I'm gonna multiply that by.
No.
81.
I want to keep things simple as far as numbers go.
5.
Let's do
10.
5. We're gonna do 5x squared. Ooh. Okay. Plus
10.
10 y, and then I'm just gonna have plus 1.
Boring.
Okay. It is boring, so we'll do 2. Okay.
Yeah, that's crazy.
All right. Okay. I don't want you to freak out, because what have I purposely thrown in there?
I swear.
I throw in an x squared, I have an x, I have y's in there, okay, cool. In fact, for the y's, let's put this y, we're gonna have y to the
Second part.
100.
What?
Oh.
I quit. Okay.
Leave
So
class.
this might look very intimidating, but when we walk through this, it's the same crap. Okay, so watch. I'm gonna take, who's first?
X, 3,
Oh,
3x.
3x is first. 3x times 5x squared. Okay, so first off is the numbers. What's the number situation?
15.
3 times 5 is 15. 15. How many x's are there going to be?
3.
X to the power of 3, because I take 1 plus 2 is 3. Cool. That's the first one. Right. Next one. 3x times 10y.
30.
30. All right. I like the 30. And then I look for the variables. What's x times y? xy.
Oh.
Great. Super easy. Because x times y, I don't know what x is, I don't know what y is, and this is still x times y. xy is x times y, right? All right. Next, 3x times 2. You basically just double it, 6x.
Nice.
Cool, that's that one. Anything mind-blowing so far?
No.
I mean, maybe the xy was mind-blowing. I don't know. What?
Yeah.
Why? Whoa. Okay. Whose turn is it
The
now?
Y100.
The y to the power of 100, okay? So this times that. How many y's are there?
1.
1 y to the power of 100, right? Okay, cool. So 1 times 5
5.
is just 5. Okay.
YX.
And then what would I write here?
YX.
I mean, x, y, and yx, no difference, right?
Yeah.
I mean, because if whatever they are, I'm just multiplying them by each other, right? X, y, yx, doesn't matter.
Do
So,
you have to write the 100?
ooh, yes, you do. What?
Is it y?
But again, x, y, yx doesn't matter. Like, just for this, like, x, y times yx,
Still the same.
at the end of the day, I don't care what numbers you choose for them. 2 times 5 is the same as 5 times 2. You know what I'm saying? Like, just, it doesn't matter, right? So,
You're gonna get the
I
100.
personally like to write the x's first, just because, I mean, it's the alphabet, right? X, Y, Z. Okay, so
What about those backwards?
I'm gonna write the x's first. How many of them are there though?
Two.
102.
2. Whoa. Can you add these together?
No.
They are not the same exponents, like terms. Okay, careful of that. Okay, y to the power of 100. All right, no problem. Okay, so 5 times 1, got it, and just slap on the variables. Okay, that's why this is not that bad. It might look like a whoa. Okay, I really like this next one, y to the power of 100 times 10y. So the numbers, 10, right, plus 10, y to the
101.
101. Very nice. Because I have 100, and I'm adding exponents because I'm multiplying, so 101, cool. And then the last one,
Y.
2, right?
2y.
plus 2y. Whoop,
100.
100.
to the power of 100. What is it? Y to the power of 100. Ran out of room there. Can you even see that?
Yeah, you can just
Another thing? Yeah, you can. It's just on the camera. Cool. All right.
Wow.
Now, can you simplify this? Oh, I hope so. Oh, man.
Oh.
Look at all this. All right. When I'm trying to simplify, what am I looking for?
Common.
Common's kind of close.
Common terms.
Common terms is interesting. What I can combine like terms. Okay, cool. All right, cool. We got all the words in there.
Adding.
Adding. All right. So, are there any x cubes?
No.
No. Are there any xy's?
Yes. The 5.
5xy.
I don't see any xy's.
What?
Time out. This is a big thing. Remember yesterday's problems or the last video's problems. When I introduced this whole thing with 2x squared plus 2x. Can I add those together?
No.
No.
Oh.
Those are not the same, right?
So there's
So
no.
if I said 2x, can I add those together?
No.
No. Those aren't the same. This is x squareds. This is x squared y. I don't know what y is, but this is going to be different than that. You know what I'm saying?
Mhm.
Those are no longer like terms, right? So whenever I say like terms, it's exactly like terms. Okay. So all right. So back to here. Are there any xy's?
No.
There's x's. There's x squared y to the 100s. There's this 101y, and then okay. See what I'm saying? So no. Are there any x's?
No.
Just x's? No. Are there any of this? That's crazy.
No.
No. Any of these?
Yes.
Where?
No.
Oh, no.
Close. I really like this problem, okay? It's really showing some stuff. Y to the power of 101 is not the same as y to 100. I mean, it's close, but they're one off, right? Just like the x's and x squareds, it's just one off. Not the same though, okay?
So close.
So, what's my final answer?
That.
That. Okay. Now, you're not going to have a problem like this on the test, but the concepts of what I just showed you here is definitely going to be on the test as far as multiplying, distributing, and then combine like terms. But I love that there were no like terms to combine, even though it's really close.